Hi, my name is Kai Sisk, and today we're going to be talking about probability. So, probability is the chance out of any given random number of options something will happen. So let's say this is a bag, and in this bag we've got 5 blue marbles and 3 white marbles. So what are the odds of picking a blue marble out of the bag if I picked one blindly? There are a few ways we could represent this. First of all, there is an area chart. So let's imagine like a spinner. It's pretty simple. So we've got this, and I'll just divide this into 8 parts. Okay, so this spinner here, this circle here is divided into 8 parts. So since we have 5 blue marbles, I will shade in 5 of these blue, and I'll leave the rest white because we've got 3 white marbles. So if you could just take a look here, see how if I were to spin a spinner, the odds that landed on a blue section are much higher than it would the odds of landing on a white section. So this is a representation of our probability. This is our area model. You can do this with multiple other shapes. You can do it with a square or sometimes other things like that, but this is the idea for an area model. So let's talk about, using the same example, we can also talk about tables. I'm going to use something a bit more complicated this time, and so I'm going to instead say what are the odds of drawing 2 blue marbles if I were to take one out of the bag, and then, you know what, I'm going to use a different bag for this. So here's another bag with, this time with only 2 marbles for simplicity. 1 blue, 1 white. So I'm going to see what the odds are for if I were to put my hand in the bag and pull out a marble, the blue marble, and put it back, and then pull the blue marble again. The odds of this being. So I'm going to use a table for this. So right here we have the odds of, we have our pull 1, and here we have, I'll just move this to the other end. And here we have the odds for pull 2. Blue, white, blue, white. So for the first pull, we pull blue or we pull white. And the second pull, we either pull blue or white. So as you can see here, the odds of us pulling blue twice in a row are 1 in 4. With a similar scenario, we can also use something like a Venn diagram for this. Venn diagrams are somewhat difficult to use, I found, but you will have to know how to use them. We've got a visual representation here. This Venn diagram is not drawn very well, but here's the representation for drawing 2 white. This is the representation for drawing 1 blue, 1 white, and this is the representation for drawing 1 blue. See how this area is about 2 times larger? This is what we mean by Venn diagram. The overlap means we have half as much space. The drawing is unfortunately not to scale, but this is the idea. Let's use one last scenario to map this out. And I'm going to be putting in one last bag of marbles. Okay, so we've got an even amount of blue and white marbles here. There's 6 total. So what I want to find is the odds of pulling a blue marble and then a white marble. So for this I'm going to use a tree diagram. So I'm going to draw all of the possibilities for what I could draw on and this is without putting a marble back in the bag. So I'm going to draw all the possibilities for what we could draw on the first pull. Blue, 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 white, white, white. And now I'm going to branch out what are the possibilities for the next marble I'm going to draw this. So this is why it's called a tree diagram. There's a lot of branches. So if I've already drawn a blue, that means there's 2 blues I can draw and 3 whites. Same is true for if I've drawn a white. So I'm just going to fill this out quickly. So what we can do here is count the number of possibilities for drawing 1 blue and 1 white. So that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then count our total possibilities. 1, 2, 3, 4, 5, 6, 7, 5 times 6. So that would give 30. So it's 5 over 30 or 1 over 2 or 50%. You can do these calculations with any of the models I've shown you. Area model, convert the fraction into a decimal, and then multiply that by 100, which gives you your percentage chance. So let's apply this to a real-world problem, and I'm going to use something from Thanksgiving in order to get in the spirit. It's around when we recorded this. Let's say you have a bowl of mashed potatoes. Ignore my bad drawing. If you've got this bowl of mashed potatoes, you know that this is enough to feed your 4 family members for Thanksgiving and maybe have some leftovers. So let's say of your 4 family members, one of them will eat about 3 spoonfuls. The second one will eat either 4 or 5 spoonfuls. The third one will eat 3, 4, or 5. And then you will eat an even 3. So yeah, you eat an even 3. So the recipe you're using gives you about, let's say 16 spoonfuls. So what are the odds that you, and like the amount of spoonfuls they eat is of 2 and 3 eat are completely random, and there's no way to know which. So you've got enough to feed the maximum amount, but what are the odds you have any leftovers? So I'm going to give you a moment to pause the video and work this out yourself, and then when we come back, I will work it out. Okay, so I hope you figured it out. You've paused it, you've solved the thing. So I'm going to go ahead and just use a tree diagram because it's the one that I want to use. So first thing we know is that there's 2 guarantees. You will eat 3 and the first person will also eat 3. So let's just subtract 6 to make this a little more simple. So we've got 10 spoonfuls left, and person 2 will eat either 3, 4, or 5. The person 3 will eat either, okay, I got them mixed up, but oh well, whatever, it doesn't change the problem. 4 or 5. So I'm just gonna, we know that they have to roll the maximum amount in order to make it so that you have no leftovers. So what we're going to do here is take the 1 in 3 chance that person 3 eats 5 spoonfuls, and the 1 in 2 chance that person 2 eats 5 spoonfuls. So what happens here is you multiply 1 over 3 times 1 over 2, because these have to happen independently, and you get a 1 in 6 chance you will not have leftovers. So that, since I asked what are the chances that you will have leftovers, that means your chances that you will are 5 in 6, which if you solve that for a decimal is equal to an 83% chance that you will have leftovers after Thanksgiving dinner. All right, thank you.